So this lesson, we're going to be having some fun with functions. We're going to be taking a look at the different types of functions. So looking at function expressions, function declarations, how function hoisting works, and the difference between when we're using the function expression and function declaration, different order where we can set the code. Also passing in arguments into the function parameters and then using those values within the function scope, how that can be changed. The newer arrow format for functions, removing the function keyword, creating immediately invoked functions, both with the arrow format, the function keyword. We can return values within the functions, those returned values to set and assign to variables, also to output into the console. Functions allow us to run blocks of code. There are two types of ways to create functions, so either function expression or function declaration. So first off, let's look at function expression. And function expressions are similar to when we create variables, where we set up a variable, and then this can be the function. I'm going to call it fun1, and then assigning to the value of fun1 an anonymous function. So on the other side of the equal sign, this is where we've got the function. Within the curly brackets is the code that we're running. So here we'll just output within the console, and I'll output the word hello. And now in order to run that block of code, we invoke the function. In order to invoke the function, you can do that with the rounded brackets. So every time we want to run that block of code, then we just invoke the function. And this is a simplified way in order to run blocks of code, and it also saves us trouble of having the repetition of the code. The function naming rules are the same as variables. For functions, you can also pass in variables. Parentheses, you can pass in different parameters. So in this case, we're going to be expecting two different values for A and B. And then within the function scope, we can make use of those values. So in this case, we'll take the value of A and we'll add it to the value of B. So within the function arguments, let's select and we'll create some different values. And even though we're running the same block of code, we're passing in different values for A and for B. And this is going to be resulting in different output within the console. When you are using function expressions, so function expression in JavaScript, they're not hoisted as function declarations. So that means that in order to use the function, you need to make the declaration of the function first, assigning it to a variable, and then at that point you can use the function. If we try to use the function code before we've assigned a value to the function, it's going to return back an error because it's not able to locate what fun1 is because the fun1 has not been initialized. And that's one of the main differences between the function declarations and function expressions. For the function expressions, they're not hoisted. Function declarations are. In order to create a function declaration, you would use the keyword function and then using the function name, and then the same format where we've got within the curly brackets, this is where we're going to be running the code. We'll pass in the two arguments as well for A and B. And now let's run the function 2. So for the function 2, because this is a function declaration, we can access the function. And the reason for this is that when function declarations are created, this function name is going to be hoisted to the top. Before each line of code gets read, it's already going to know that fun2 is assigned to a function, and then when it encounters the code, it knows that this function is already registered, it's already hoisted, and that's why it's able to make use of it before we actually have the function statement. A function expression can also be used as an immediately invoked function expression, which essentially runs the code as soon as it's declared, wrapping the function within the rounded brackets using the function keyword. And then this is where we're going to be running the block of code, and we'll output JS ready into the console. And in order to invoke it, just like the other functions when we're invoking them, we use the rounded brackets in order to invoke the function code. And when this line of code is encountered, it immediately runs this function, and this is what's known as an immediately invoked function expression, or IIFE. The arrow format, so this is a newer format for creating functions. Instead of using the keyword function, we can create the function just using the arrow format. So the structure would be where we're creating the function, the rounded brackets, arrow greater than symbol, with the curly brackets. This is where the function code would be running. And then pass in a value for A and B, code for fun number 3. And there's also an even shorter format for this, where you can skip the curly brackets, and whatever is added here is actually the returned value. So let's give it a new name of fun4, and then we'll invoke this function as well. So this is just the same thing written on one line of code. The immediately invoked functions, you can do this as an anonymous function, and that's going to be invoking the code. So setting up the arrow format, so that will immediately invoke the function content within the line of code. And this can also even be shortened, just as we did before, the curly brackets, and have everything within the one statement. So this will also invoke the function immediately. Functions can also return values, and when the function block of code is run, it's not complete until it actually returns the value. So in these cases, when we're invoking the function, we're not returning back a value. So if we clear the console, we do get a response back, but we also see undefined within the console. So creating another function, we'll take in the 2 arguments, return back the result of A plus B. In the code for fun5, so pass in some values into fun5, and we'll see what happens. I'll also do a console clear, as we've got quite a bit of stuff going on in the console. So this line of code is going to clear out the console, and we don't see anything being returned back for this value. So let's try that immediately within the console, and we see that we get the response back of the value. So this value is being returned back, but we're not actually capturing it or doing anything with it. So if we wanted to, we could set it up as a variable and then assign the response back as the value of the variable. So we can output the val1, and that will output the value that's been returned back. In addition, we can also just do it directly within the console. So invoking the function and then outputting the result directly into the console. Functions also have scope. So when we look at JavaScript code and we encounter the curly brackets, that means that this block of code is running within a particular scope. And I'm also going to change this to a let, so that way we can update the values if needed. And within this function, I'm going to call this one fun6. It's going to have a value of A and B, and we'll return back the value of A and B. A function, if we take the value of val2, 1000, and then after the code runs, let's take a look and we'll see what we've got for the value of val2. The console fun6, pass in some values there. So the value of val2, we're running the code. In line 54, we've got a value of 3. And then we've got a value of 1000. So initially the value of val2 is going to be 100, as we see in this line of code. So what happens if I redeclare a new variable? And I'm going to call that val2. Let's see what the value of val2 now comes back to be. We throw an error, because now what's happened is that within this block of code, we're trying to access val2, and we're throwing an error because it's trying to get this current block of code within this scope, that value of val. So we're not able to output it before we have declared it. So the code is aware that we've set val2 as a value, and it's no longer looking to the parent scope, it's looking within the internal scope for the value of val2. So in order to correct this, let's update this. And now we see within fun6, when it gets invoked, we get a value of val2 as 1000, and when we go out of the function scope, the value of val2 is back to 100. So these two variables, even though they have the same name, they're not the same variables, because this one is only available within the scope of the function, as we're redeclaring the variable by using the let keyword, and that's why we're only able to access this current value within the scope of the function, and once we go back out of the function, that val2 has not been updated. It's still the original value of 100. The benefit of using functions is that you can write the code once and reuse it as many times as needed. So you can pass in different arguments and then return back different values depending on the arguments that are passed in. So with functions, we'll create another function example. And for this one, we're going to be using a and b. And we're not going to be passing in any values for a and b, but we will be returning back a plus b, just as we've done in the other functions. So what happens if we run the function and we don't have a value set for a and b? Let's see what returns back. So we're just invoking the function. We're not passing any values. We get a value of none being returned back, as that result is not a number. If you console log what we have for a and b, you can see that both of them are being returned back as undefined. If we put only one value in, that's going to be referred to as a, and there's going to be no value for b, and b is going to be coming back as undefined. So when we add undefined and 10, that's where we're going to get the non being returned within this statement. So we can also assign values to it. So we can check to see if a is equal to a value, or we can set a default value for a. So in this case, a will have a value of 10 if there's nothing defined. And we can do the same for b, where we can set a value of b, and let's set the default value of b to 50. So this way, if no value for a is assigned, it will take a value of 10. You can see that in the console. If no value of b is assigned, it will take a value of 50, and resulting in a total of 60 being returned back. Do add in a value for a, we're going to have the value of a of 9, value of b is going to be 50, resulting in a returned response of 59. Now there's also another way that we can do this, where we can set the default values within the function. And this is a newer format for doing this. So we can set a value with the equal sign, and then using the equal sign for b to be 50. So we can remove out that statement, and now let's try running the fun8 function that was just created. It's going to be resulting in the default values of a of 10 and b of 50, and sending it back as 60. So here, just as the other example, if we do add in a value, the first value that we're passing in, the first argument, is going to be assigned to a. The second one is going to be assigned to b. As well, within the console, the value of a becomes 8. Was no value in the arguments, then this would be set to default of 10, whereas the value of b is 50 because there's no second argument within the function call, where we're getting the value of 58 being returned back. Try it out. Try out the different functions. Create the immediately invoked functions. Try out how you can set variables and how you can declare variables, what happens when you declare them within the function scope, and if they have the same variable name as the parent variable. Log it out into the console. Also set some default values for your variables, and you'll be ready to move on to the next lesson.